Okay, so in this lesson, we're going to learn how to multiply radicals and then simplify. Let's review a couple of problems. So suppose we want to simplify, let's say the square root of x to the square is x to the second power y to the 6. All right, so we did this in a previous lesson. Now this one's easy. And then first of all, let's assume that all variables represent non-negative real numbers. So all variables represent positive numbers. So in that case, you don't have to worry about absolute value. Okay, so this is an easy kind, remember, because the exponents are even. So the index is 2. Remember, the square root, so the index is 2. So basically, we said that the square root of x squared is just x because 2 divided by 2 is 1. And the square root of, remember, this is square root of x squared times the square root of y to the 6. And the square root of y to the 6 is y cubed because 6 divided by 2 is 3. So that was a shortcut. All right. Number 2, remember we had this now. We had square root of x to the 5th power times y to the 8th power. Now that's a situation where this exponent's even. That's a good, that's what we want. This is odd, so we have to do a little bit of work. So remember what we did was we asked ourselves, what's the largest even number less than 5? So the answer was 4. So what we did was we wrote this as x to the 4th times x, because x to the 4th times x is x to the 5th, and we left this one as y to the 8th. And then we simplified x to the 4th, and we simplified the square root of y to the 8th. So the square root of x to the 4th is going to be x squared, because 4 divided by the index 2 is 2. And the square root of y to the 8th is going to be y to the 4th, because 8 divided by 2 is 4. And we're left with the square root of x. Okay, so that was a quick review. All right, now let's simplify the following. Okay, number 1. Suppose we had the square root of x to the 4th y squared times the square root of x y to the 9th. Okay, so what I would do first is remember what we did in a previous lesson where we had the square root of 2x times the square root of 3. So the radicand, if the index are the same, then we can just multiply the radicands together. So that's going to be the square root of 6x. Okay, so we can use that idea here. So let's multiply the radicands together. So that's going to be the square root of x to the 4th times x. So remember, when you multiply like bases, you add exponents. So x to the 4th times x will be x to the 5th. Y squared times y to the 9th will be y to the 11th. Okay, now let's simplify this like we did these right here, number 1 and 2. So that's going to be the square root of, okay, so the largest integer, the largest even number less than 5 is x to the 4th, and the largest even number less than 11 is 10. So I get x to the 4th times x plus times y to the 10th times y, and I'm going to simplify the square root of x to the 4th, and I'm going to simplify the square root of y to the 10th, and I get the answer being x squared y to the 5th times the square root of xy. All right, number 2. Suppose we had the square root of 2x to the 6th times the square root of 10x squared. All right, so again, using the fact that since the index is the same, these are all going to be square roots, so I just need to multiply the radicands together. So I'm going to get the square root of 2 times 10 is 20. X to the 6th times x to the 2nd power is x to the 8th power. So when you multiply like bases, you add exponents. Remember the product rule. All right, so now I get, first of all, the exponent of the variable is even, so I'm going to leave that alone. 20, though, is not a perfect square, but besides 1, the other perfect square that goes into 20 is 4. So I'm going to write this as the square root of 4 times 5 times x to the 8th. And I'm going to circle these two because those are the two I can take the square root of and get a nice number, or get something nice. So that will be the square root of 4 is 2. The square root of x to the 8th will be x to the 4th. I'm left with the square root of 5. Okay, number 3. You have the square root of 3x squared y times the square root of 15 x to the 5th y to the 4th. Okay, so 3 times 15 is going to be 45. X squared times x to the 5th is x to the 7th. Y times y to the 4th is y to the 5th. And then let's simplify this. The perfect square that goes into 45, the largest one will be 9. So I get the square root of 9 times 5. X to the 7th, remember, use the largest integer, even integer that's less than 7. So it'll be 6. So x to the 6 times x. For y to the 5th, we're going to use y to the 4th. So y to the 4th times y. And then I'm going to circle the ones that I can take the square root of. So I'm going to get the square root of 9 is 3. The square root of x to the 6, 6 divided by 2 is 3. And then y to the 4th, the square root of y to the 4th, 4 divided by 2 is 2. And I'm left with the square root of y, 5, x, y. Okay, number 4. You have the square root of 8 x to the 5th y times the square root of 12 x y to the 4th. So the square root of 8 x to the 5th y times the square root of 12 x y to the 4th. Okay, so 8 times 12 is 96, so the square root of 96. X to the 5th times x is x to the 6. Y times y to the 4th is y to the 5th. All right, so that's where I'm at. Okay, now let's look at a perfect square, the largest perfect square that go to 96. So let's kind of figure this thing out. So let's see. Let's try 4. So 96 divided by 4 is 24, so that's 4 times 24. Now notice 4 is not the largest, okay, but try and use the largest. Because 4 is not the largest, because I also know they see that 24? 24 I can write as 4 times 6, so then I'm going to get 4 times 4, which is 16. So 16 is going to be the largest perfect square that that will go into 96. I'm going to get the square root of 16 times, all right, and then it will be 16 times 6. Times 6 times, this is already even, so I'm going to leave it x to the 6. Y to the 5th, I'm going to rewrite as y to the 4th times y. Okay, I'm going to circle the square root of 16, square root of x to the 6, and the square root of y to the 4th. Because the square root of 16 we know is 4. The square root of x to the 6 we know is x to the 3rd. The square root of y to the 4th we know is y squared. And we're left with the square root of 6y. Number 5. Suppose we had the square root of 28xy times the square root of 2y cubed. All right, so 28 times 2 is 56. X, there's no x here, so that's going to be an x. Y times y cubed is y to the 4th. And let's see, for the square root of 56, let's kind of figure that out. Let's see if 4 will go to 56. So 56 divided by 4 is 14, so it does. So I get 4 times 14. And 4 is the largest because there's no, besides 1, there's no other perfect square that goes into 14. So I'm going to rewrite 56 right here as the square root of 4 times 14 times x, and then times y to the 4th. Okay, 4 was already even, so leave it alone. So I'm going to circle the square root of 4, and I'm going to circle the square root of y to the 4th. So the square root of 4 is 2. The square root of y to the 4th is y squared, and you're left with a square root of 14x. All right, number 6. You have the square root of x to the 6, y squared, times the square root of x cubed y, times the square root of y. Okay, so x to the 6 times x cubed, that's going to be x to the 9th. y squared times y. So when you multiply like bases, you add exponents. 2 plus 1 is 4. And then I'm going to simplify. I'm going to rewrite x to the ninth. The largest even number, less than 9, is 8. So I'm going to write this as x to the 8th times x times y to the 4th. And I'm going to circle these. And so I get the square root of x to the 8th is going to be x to the 4th. The square root of y to the 4th is going to be y squared. And you're left with the square root of x. All right, and finally, number 7, you have the square root of 10xy times the square root of 20x cubed y squared. All right, and so 10 times 20 is 200. And then x times x cubed, when you multiply like bases, you add exponents. So x times x cubed is x to the 4th. And then y times y squared is y cubed. So remember, the reason why you can do this is because the indexes are the same. So they're both 2, so you can just multiply the radicands together. And I'm going to rewrite this as the square root of 100 times 2, because 100 is the largest perfect square that goes into 200. 4 is even, so I'm going to leave it at x to the 4th. Y cubed, though, I'm going to rewrite as y squared times y. And so I'm going to circle these, because I can simplify those. So the square root of 100 is 10. The square root of x to the 4th is x squared. The square root of y squared is y. And you're left with the square root of 2y. Okay? All right, so that's going to take care of this part dealing with multiplying radicals.